Friends, today we'll discuss the third video of thermodynamics concept for engine design series. So here we'll discuss the Raoults law limitation for application. In previous video we have discussed what is Raoults law for ideal liquids and modified Raoults law for non-ideal liquids. So the Raoults law also has some limitations for applications. So today we are going to teach you what is Raoults law limitations for application and what are the alternatives. So this is about me. I'm a presenter, Lokesh Kumar Singh, CUMD Petro Horizon Oil and Gas Engineering Private Limited, and this is about my education qualification and my experience. You can also visit our company website petrohorizon.com to get the direct link of our YouTube videos. So Raoults law has some limitation while applying to Vapour-Liquid-Equillibrium system calculation. In this video, we are going to discuss those limitations of Raoults law application and how to deal with those limitations. As design engineer always play with limitation while designing equipment or doing process simulation optimization for revamping, capex, capacity enhancement, modification, adequacy check, debottlenecking of the equipments or unit operation or plants. Therefore, it is necessary for a design engineer to know the limitation of widely used Raoults law for Vapour-Liquid equilibrium calculation so that design engineer could reach more accuracy in design calculation and optimization. So what is Raoults law limitations? Raoults law is not applicable for a component whose critical temperature is less than the temperature of application. Take an example. This is air water system which is in equilibrium. So as air and water system is in equilibrium at atmospheric temperature, let's say 30 degrees centigrade, Raoults law is not applicable for the component air because the critical temperature of air is less than the application temperature 30 degrees centigrade. You might be knowing that the air boiling point is around minus 194. So its critical pressure is less than, far less than 30 degrees centigrade. It's around in minus actually. Therefore, this Raoults law we cannot apply for this air component. We can apply Raoults law for the second component, water, but we cannot apply for air because the water critical pressure is critical temperature is much higher than 30 degrees centigrade. So Raoults law is applicable for water component but not applicable for air component. So now we see the mole fraction of water in the air Y is usually calculated when Raoults law applied to the component 2, means which is water, with the assumption that no air dissolve in the liquid phase. Thus the liquid water, which is component 2, is regarded as a pure, and Raoults law for water become this one, YIP equal to XI PI set. So from here we can calculate we can apply this for the component 2, which is water. So it become Y2 P equal to X2 P2 set, where 2 indicates the component 2, which is water. So considering sigma Xi equal to 1, so Yi become Pi set upon P, and for water, if we apply this for water, so Y2 equal to P2 set upon P. So if we check P2 at 30 degrees centigrade, the saturation temperature of saturation pressure of water is 3.2 kilopascal. We can see from the steam table where the saturation where the vapor pressure of pure water is given at various temperature and pressure conditions. So from there you can get this value 3.2 kilopascal, and this is the total pressure, which is atmospheric pressure, because we are considering this system air water system at atmospheric pressure. So the Y2 component comes to 0.0313. This means this is 3.13. It means at 30 degrees centigrade and atmospheric pressure in an air water equilibrium system, only 3.13% of water vapor is present in the air at equilibrium condition. So how we have taken this sigma xi equal to 1? This is the main question. So see here, the assumption says that no air dissolve in the liquid phase. This means the liquid phase is itself complete into water, because in water there is no other component dissolved, means there is no air, so whatever is water, it's complete in itself. So that's why we say that sigma xi equal to 1. If there is some gas or air dissolved in water, that at that time sigma xi is not equal to 1. So when we take this assumption, at that time we can say that sigma xi equal to 1. Okay. So what I mean to tell you, see, so one Raoults law limitation, you understand that we cannot apply for the air. That means Raoults law only applicable to calculate the amount of vapor present in air. But if we want to calculate the air dissolved in water, we cannot apply Raoults law. Then we need a alternatives law. So that alternatives law is Henry law. So in the next video, we'll teach you how Raoults law and Henry laws together solves the problem of this air-water equilibrium calculations. So for this water, we will apply Raoults law to calculate the vapor fraction of water present in air at equilibrium condition 30 degrees centigrade and 1 atmosphere, and for calculating how much air is dissolved in water at 30 degrees centigrade and 1 atmospheric pressure, we'll use the Henry laws. So in the next video, I'm going to teach you how to calculate the amount of air dissolved in water. So this was all. So note that if one wishes to calculate the mole fraction of component air in the water, then Raoults law cannot be applied. This problem can be solved by Henry laws, as I told you. So this is all about Raoults law limitations for applications. You understand, because Raoults law have limitations uh, for those component which has critical temperature below application temperature. So thanks for watching. So this is about Petro-Horizon offering for petroleum, chemical and mechanical engineering student. We provide 1 month value-added training courses, which is 60-hour training. Training fees 10,000, 15,000. This value-added training courses, you can visit our company website www.petrohorizon.com. There if you go in training section, so you will find that the value-added training courses for universities and colleges, and you will find a list of value-added training courses. By doing these value-added training courses, you can enhance your technical as well as design skills, and these courses are available for first year, second year, third year, and final year students. These value-added training course will give you the design concept and the super concept in your technical understanding of the subjects, related subject to those value-added training courses, and you can perform very well in your curriculum as well as in your on-campus job interview. And our second course is a 6-month engineering design skill development training and placement assistance. This is for third year and final year student. This is 300 hours rigorous training and certification program. So here the training fees is 50,000, can be paid in installments. So this is for chemical, petroleum and mechanical engineering students. So we provide free consultation to third year and final year students for selecting the project work. because in third and final year students they need to do the project work. So we provide the consultation which is free of cost, and it will make you stand out of the crowd if you do the design project work in your curriculum work. We are also providing 3 days demo training and awareness classes at Dehradun company office to know what exactly is design engineering, because most of the students don't know that is engineering design. What is engineering design? Because if somebody told them we are design engineer, they understand it's AutoCAD, but it's nothing to do with AutoCAD, because in design we use a lot of standards, codes and concept which is used in designing equipments of oil and gas, refinery, petrochemicals and chemicals fields. So we are successfully running 2 batches since May 2017. As one is value-added training courses, which is the foundation course for S1 high-SS simulation, which is 1 month, and the second course is mechanical design engineering batch course, which is 6 months. So we keep the number of student maximum 10 to keep the full attention and make their concept crystal clear. You can contact for any query to us on petrohorizon@gmail.com. Email this is email ID info@petrohorizon.com. You can contact on these numbers also, and this is our company address. You can visit our company office to discuss with us about whatever is your queries and consultation. So please subscribe to our YouTube channel to get updated with new video. You can also visit our company website petrohorizon where you will get the direct link for our all YouTube videos. So thanks a lot once again.